Okay, so I want to talk about section 0.5, which is polynomials. Now, even though I'm focusing on section 0.5 polynomials, I would like to mention just a little bit about section 0.4, but you can focus on the polynomial homework, which is going to be 3, 11, 21, 23, and 29. Now, the main thing that they're going to talk about in section 0.4, which we are essentially skipping, is going to be absolute value inequalities. So I just want to briefly touch on absolute value inequalities and equations. And then the main focus of this section is going to be polynomial division, because I'm guessing that a lot of you have seen polynomials before, but maybe polynomial division is not something that you're super familiar with. So let's quickly deal with these absolute value inequalities and equations. So this is the kind of thing that section 0.4 is going to focus on. And I would recommend flipping through section 0.4. I just don't want to spend a lot of time on it. And they're going to say things like solve for x. And they're going to have the absolute value of x minus 2 equals 3. So solution. You remember we want to rewrite the equation or inequality whenever we can. So absolute value of x minus 2 equals 3. Well, we have two sort of choices here. So the absolute value of x minus 2 means if x minus 2 is greater than or equal to 0, then we just do x minus 2. So then we just solve this for x minus 2 equals 3, and this goes to, well, we add 2 to both sides, and we get x equals 5. So that's our solution if x minus 2 is greater than or equal to 0. Then if the quantity x minus 2 is less than 0, we're going to deal with negative x minus 2. We're going to set that equal to 3. Well, this would imply that x minus 2 equals negative 3, add 2 to both sides, and we get that x equals negative 1. So our two answers would be negative 1 or 5. So we put a box around both of those to indicate those are both answers. That's an absolute value equation. An absolute value inequality then. So we got basically two types. Solve for x. We've got less than types and greater than types. And of course, it's either less than or equal to, or less than, greater than or equal to, or greater than. But I'm just going to focus on one of each. So let's do, let's say x plus 1 is less than 3. All right. So let's do x plus 1 is less than 3. Solve for x. So in order to do this, when I have an inequality, if I have an inequality with less than, I can do what I call unfolding the inequality, which is I can deal with both of the inequalities at once. Because here in this previous example, this is actually two equations. It's saying x minus 2 equals 3, which we have here, or negative x minus 2 equals 3, which we have here. This is going to be two inequalities. It's saying x plus 1 is less than 3, or negative x plus 1 is less than 3. Now, in this case, when we have a less than, it's going to be both of them. So I can write this as negative 3 is less than x plus 1 is less than 3. I'm skipping some steps here. Actually, I'm breaking my own rule. So I want to write this down again. X plus 1 is strictly less than 3. So this goes to either this, so I have x plus 1 is less than 3, or this, negative x plus 1 is less than 3. Now in this case, I want to multiply both sides by a minus sign, and if I multiply both sides by a minus sign, then I've got to flip my inequality. So I've got x plus 1 is greater than negative 3. Well, if I put these two things together, then I have what I said before, which is x plus 1 in the middle. We've got less than 3 on the right and greater than negative 3 on the left. Now I can finish this up in one quick step. So I'll copy this to the next page. By the time it's taken me to copy this thing and paste it, I may as well have just rewritten it. But to finish, I'll subtract 1 from both sides. sorry, from all three parts, I guess, and I'll get -4 is less than x is less than 2. And this is a great answer. You can stop there. You could also write this as -4, comma 2 with parentheses, because these are, I got a little aggressive there, because these are strict inequalities. Or, like I said before, you could use the real number line. I like the 0. It's not required. And you could say, fill in the space between those two, or, like I like to do, make the little train car. Finally, the last example I want to do from section 0.4 is solve for x. And it's something where we have, say, a greater than instead of a less than. So we have, let's do absolute value of 2x is greater than 4. Now what this is going to do, so solution, we've got absolute value of 2x is greater than 4. So again, I'm going to either have 2x is positive, in which case I've got just 2x is greater than 4, and I can solve that, or I have 2x is negative, and then that means negative 2x is greater than 4. So in this case, I divide both sides by 2, and I get x is greater than 2. So that's one possible answer. The other possible answer is I divide both sides by -2. Again, when I divide by a negative, I need to flip that inequality. So this becomes x is less than -2. Now, the previous answer had overlapping sets. These sets are disjoint. So we can either say, this or that. You can put those together. Or you can use the interval notation and say -infinity up to -2 with the parentheses union, remember we learned the union symbol, 2 up to infinity. Okay, so something like that. Now again, if instead of having here, if we had greater than or equal to instead of greater than, then we'd just have square brackets here. So that's kind of the whole gist of section 0.4. Like I said, flip through it, but I think the book goes into a bit more detail than I really want to, and we're going to end up seeing the things from that we need later anyway. So on to the sort of the main course for this section, which is polynomial division. So I want to do a simple polynomial division example, and then I want to do a more complicated polynomial division example. So the first example is going to be something like this. So I'll say simplify. I always had a rough time, simplify and evaluate. Simplify means go one way, evaluate means go the other way, right? So simplify or evaluate. Simplify, and I'm going to write x squared minus 1 over x minus 1. Now I'm going to take a sip of my tea, and I'm going to ask you to think about how you do that, or maybe try to work that out. You can also pause the video. Okay, well, solution. One way to do this is to know that this numerator is a difference of squares. So I know that x squared minus 1 factors into x minus 1 times x plus 1. Now I've got x minus 1 on the bottom, and I've got the same factor on the numerator and denominator. I can cancel those, and my final answer is x plus 1. Now, of course, if this expression was being used, somewhere in a function or something, something that we might see later, and there is a possibility of x equaling 1, there could be a problem, okay? But for our purposes, we can say, x plus 1. If you wanted to be really pedantic, you could also make the note x does not equal 1, right? But I'm okay with just leaving it like this. Again, I do care about details, but I really care about you getting the underlying concepts. And if you can get the underlying concepts really well, then you can sort out the details. So this is what I want to see. Let's do something a little bit more complicated, though. What if I asked you to simplify or evaluate or whatever x cubed plus 2x minus 3 over x plus 1. So what would this be? Now this to me is a little bit harder. So what I'm going to do is I'm going to push pause on this. and I'm going to come up here and do a little aside on long division. So let's go off into our little fantasy land. So this is a thought bubble. This is a fantasy land. And what do you guys fantasize about? You don't have to say, because I already know. You fantasize about long division. I think long division was everybody's favorite thing growing up, right? I'm not alone in this. I don't hear anyone disagreeing, so therefore I must be right. Okay, obviously long division is the worst, but let's go back to this troublesome childhood memory for a moment. So if I have 17 divided by 5, I put 17 inside the house, and I put 5 outside the house. What do? We see how many times does 5 go into 1. 5 doesn't go into 1, so we move on. Okay, how many times does 5 go into 17? 5 goes into 17 3 times, so we put a 3 up here. And what is 5 times 3? 5 times 3 is 15. We subtract these, and we get 2. And we say 3, remainder 2, and that's our final answer. And then we get candy. Yay! Candy! Okay, remember when like a lollipop would totally make your day? Yeah, that was nice. Okay, well, so let's go a little bit further now. Let's go and look at long division with polynomials. Well, here when we were looking at long division, we were looking at long division in base 10. Here we're looking at long division in base x, sort of. So I'm going to write out the long division thing. I'm going to write x plus 1, so solution. I'm going to write x plus 1 on the outside of the house. On the inside of the house, I'm going to write an expression related to this. I'm going to write x cubed plus 0x squared plus 2x minus 3. Okay, so you notice that the original expression up here, there's no 0x squared. There's no x squared term. I need this as a placeholder, just like... So going off to the side here again, just like 101 is not the same as 11. We need that 0 as a placeholder. Okay? So how many times does x go into x cubed? Or more precisely, how many times does x plus 1 go into x cubed plus 0x squared? Well, it goes in there x squared times. Unlike with our numerical long division up here, we can be off by a lower order. So here, you know, I couldn't choose a number bigger than 15. If I chose something bigger than 15, I'd be getting a negative remainder, and that wasn't a thing back then. Here, it's okay to get a negative remainder just as long as it has a lower power of x. So x squared times x gives me x cubed, plus x squared times 1 gives me 1x squared. Then I subtract these, get x cubed minus x cubed is 0. I get 0x squared minus x squared gives me negative x squared. And then I bring down my next term. So I add 2x. Now how many times does x plus 1 go into x squared plus 2x? Well, it goes in there minus x times, negative x times. So negative x times a positive x gives me negative x squared. Plus, I shouldn't say plus because it's not going to be positive, negative x times a positive 1 gives me minus x. And now I subtract these. So I've got, I guess I should emphasize that I'm subtracting the whole thing. I've got negative x squared minus a negative x squared, which is going to give me 0x squared. It's set up that way on purpose. And then I have 2x minus a negative x, which leaves me with 3x. So I've got 3x minus 3. And things are looking pretty good. Like, oh yeah, maybe I just multiply this by 3, right? So then how many times does x go into 3x? It goes in there 3 times. Sweet. So we multiply x plus 1 by 3. We get 3x plus 3, and that looks a little different, but maybe everything will come out in the wash when we subtract. 3x minus 3x gives me 0, but I've got negative 3 minus positive 3. This gives me negative 6. That's okay. Just like we did back in younger times, we're going to say there's a remainder of negative 6. And our final answer is going to be this right here. You can also write this as x cubed. Oh, that's not how we write cubed. X cubed plus 2x minus 3 divided by x plus 1 equals this polynomial, x squared minus x plus 3, plus the remainder term, which is negative 6 divided by x plus 1. You could also say just minus 6 over x plus 1. But this is also a fine answer. So I want you to review this polynomial long division, look over section 0.5, and definitely skim over section 0.4. Thank